Okay, well, we don't propagate plants on anything like the scale you've just seen. I hope it won't be too much sublime to the ridiculous, but anyway, you can judge that. Where do I start? I've got 30 years to get through and lots of slides, so please don't go to sleep at the back too much. I thought I'd tell you a little bit about who I am, who we are. Hopefully a fairly simple guide to what micropropagation is all about. There are a few people who know as much as I do about microprop in the audience, so hope I won't bore them too much. A little bit about why I think we might have succeeded. I think we have anyway, nobody's told me I haven't. Where perhaps some other labs have closed and why we hope to continue. A little bit about a few specific projects that we've had and our latest planet-saving product, we hope. Okay, Barbara and I started the business lots and lots of years ago. We're still a family business, quite small, certainly compared with our Israeli. Not competitors in any way, I don't think, but we do different plants. We deal mostly with woody plants. Some of the more difficult things, some that are fairly simple, but for different reasons. We sell quite a lot of our plants through our catalogue, but we increasingly do specific plants for specific customers on contract. That seems to have increased over the years. Idiot's Guide to Micropropagation. First, the medium we put the plants into has to have everything the plant needs to make it grow. So that includes all the normal things that you'd feed to plants. The major elements, NPK requirement, all the trace elements, vitamins and sugar. The sugar is essential to get rapid growth. Don't put it in your compost because it tends to make things go a bit mouldy. We then have to put in growth regulators because we want to control the growth of the plant. And then we put in agar, which sets it, and that just gives us a surface on which to put the plants. It has to be sterilised, and we use a fancy machine called an autoclave. Pressure cookers work quite well, and that's all this really is, just a big one. Stock plants. We've heard all about the importance of stock plants. They are the most critical bit. If you start with a stock plant that's got a disease, the chances are you'll end up with not very good plants. Viruses can be eliminated. We don't do it ourselves, and if we start with a plant that's got virus, there's a good chance we'll end up propagating virus-infected plants. So the stock plant is critical. And we would normally grow them under clean conditions and check them out before we start putting them into culture. For initiation, we take young shoots that are growing rapidly and discard most of it. We don't like these horrible things called leaves, they're all dirty, so we chop them all off. The bit we want is actually that little bud in the leaf axil. The rest of the plant is immaterial, we just want a small bud that we can sterilise. Sterilisation, very simple. You chuck it into domestos, kills all known germs. Kills the plant too if you leave it too long, so the timing is rather critical there, and that will vary depending on what the plant is. Once it's sterilised, we'll put it onto culture medium, and hopefully, if we've got the medium right, we'll get some growth. If we put it in a nice warm growing room, keep it lit and at the relevant temperature, which is normally 20 to 25 centigrade. If we get it wrong and the domestos doesn't work, that's what happens, because we've got sugar in the medium to make the plant grow, but it also grows all sorts of other things. And this is where most fungal diseases will show up. If the plant has got a fungal disease, then the chances are that it will show up at this stage and it won't go any further. You've probably all seen laminar flow cabinets. These are basically cabinets in which air flows out from the filter at the back over the work surface to keep it completely sterile. I think our conditions are probably only a little bit cleaner than they use in the stock plant glass houses, but probably as cleaner, I suspect, than Queen's Medical Centre. We don't carry out operations other than on plants, hopefully. Okay, the work surface is a sterilised card. The handling of the plant material has to be done with sterilised forceps and scalpel, and it's a fairly labour-intensive job. Once the pieces are put into culture, a few weeks, and we'll get some significant growth, and we get very rapid growth because in the culture medium is everything the plant needs to grow. After division and putting onto fresh medium, we'll get jarfuls of plant material, and we can get fairly rapid bulk up of material. We're getting something like a 3-fold increase in plant material every month. So that might not sound very much until you start multiplying it up. By the end of the year, you're knee deep in them if you carry on doing the multiplication. You do need also to be knee deep in workers to handle them, of course. So the multiplication process is fairly rapid, and we can then get to this stage. We can then start cutting off shoots for rooting, and those will be first put into a rooting medium and kept in a growing room until they're at least triggered to root, so they're getting to the root initials, and then they'll be put into the plugs. Compost being a critical element of what we do, we use paper pots with our own compost mix so that we can control exactly what we put in, because different plants will require different mix. Weaning, as we've heard, is the critical bit. We use a mist jet that's much the same as the Israelis are using. It produces a sort of, not quite a fog, it's a mist, but which settles out eventually, but it does humidify the air as well. So we're getting a high humidity, a certain amount of leaf wetting, which I think is essential. We obviously control temperature and air temperature and the floor temperature. That's crucial to get uniformity. In this country we have to supply extra lighting as well, something I'm sure the Israelis don't have a problem with, the amount of light. We do sometimes get too much light and have to use screens to screen it out, but that's a rare event. One thing I would point out, we use the evaposensor for the control of the mist, which works extremely well. It's definitely a very good way of controlling the amount of mist that you put onto weaning plants and rooting cuttings. The evaposensors have to be maintained a little bit, but they give us a very good reading. It integrates over time, and the mist control is much better than we've ever had with any other system. Okay, weaning. After 2 to 3 weeks, we would expect to see roots coming out of our plugs, and we can then move them on into the next stage. This shows very nicely the fact that when you micropropagate plants, you tend to get nice bushy little plants because you've got lots of nodes down in the base of the plant because they're like miniature plants. And that's largely why micropropagated plants tend to bush better, because you've got more potential to produce bushy plants. So they do tend to branch nearer the base better. Okay. Clearly, once they're weaned, once they're rooted, we then need to wean them off and harden them off. There's my dear wife among the plants, ready for dispatch, we hope. Okay, why would we want to micropropagate plants? I often ask myself that. Anyway, clearly microp can be used for routine propagation. It's giving us clonal stock, which is critical. We're starting often from a small number of plants and propagating them. We're wanting to propagate a lot of identical plants. If it's an improved variety, then bulking up is much more rapid by micropropagation often. It produces juvenile plants, which can, as I said, we tend to produce a bushier plant more easily, and that can be critical in some plants. The main reason microprop's being used is this large bulk up potential compared with traditional methods. And clearly, if you've got a nice clean stock plant, then you may want to keep it that way. So microprop can be used simply to store clean plants, because if you put it into a culture vessel, you can maintain it there nice and clean under sterile conditions, and then bring it out months, years later if that's what's required. So it can simply be used to store plants and then supply stock plants later, or perhaps a continuous supply of stock plants. So why have many labs in the UK closed? I think it's mainly down to labour costs, although I think some labs have made other mistakes, investing far too much money in some cases and not able to get a return on that. But labour is expensive in this country. Handling plants under sterile conditions takes time. And if you get it wrong, if you rush it, then you don't have sterile plants. That's even more expensive. Our productivity is something around 100 plants an hour from the lab, and we think that's quite good. But compared with sticking cuttings, that's quite expensive. Large-scale production seems to have moved mostly east into Eastern Europe, into India, in a huge way sort of 15 years ago into India, and now largely into China. They have a lot of people who work for a lot less than my employees do. So you'll see some huge labs in those parts of the world producing large quantities of plants, which we can't really do economically. They're doing plants that you just wouldn't do in this country because it's too costly. However, we have managed to survive, and we've done that largely because we've not invested huge amounts of money, mostly because I didn't have it. At times I wish I'd had a little bit more, but one does tend to learn how to survive with a piece of string if necessary. And then we've looked for niche markets. We've gone for the subjects that are a little bit more difficult than perhaps the Chinese and Indian labs that are just setting up are able to do. And they are, the foreign labs are largely set up to do large quantities routinely, and they do that very well. We've tried to set ourselves up to do reasonably large quantities if required, but of slightly more difficult things that need a little bit more fiddling about with. Any new enterprise set up tends to lack the expertise and knowledge necessary to do new plants and things that are a little bit more difficult. Where we've started doing plants, but require large volumes, we've passed those on to some of these labs because it's pointless us trying to compete. So some of the plants that we've tried to do, we've initiated them into culture and then we pass them on to somebody else. We've done various projects, and there's a few things here. We've been involved in rescuing some English elms and propagating those for the British elm experiment, where they're being planted all over the country to see whether they are resistant to Dutch elm. And it'll be interesting to see in 10, 20 years' time whether they turn out to be. And then there may be a big project propagating elm trees. We do all sorts of other trees, and we do things like roses, which are fairly easy to do, but you don't want 500,000 of one particular rose. You want lots and lots of varieties, and that's where we can cope with that. We can take a new variety from a breeder and bulk that up fairly quickly and get it into production. Here we've got a few things that we've managed to do IPPS style, I would say. We saw the, well, if we start in the lab, so we've taken a scientific technique and we've tried to make it simpler and just ergonomically simpler. So handling things is done in the most efficient way, so that the labour we've got, we are using efficiently and getting them to work efficiently. But on the nursery, we've also done a few things which make life simpler. We make all our own plugs with our Alipop machine, which is a wonderful machine to buy. I wish I could have made one rather than spend a fortune on buying one, but then. So we have made a few machines. We've got our trimming machine, which is it's actually called Nunu. I wish I could show it to you all. Some of you will have seen it. It basically consists of vacuum cleaners in reverse that blow air in to blow the plants onto a cutter, and inside the chamber there is just a hedge trimmer, and it does the same job as our Israeli gentleman's trimming machine, but it will handle any sort of plant, and it doesn't have to be stood up beautifully for the hedge cutter. And of course it's all based on a Danish trolley, which is essential. We also use slow sand filters for filtering our water. We collect all rainwater, so we're getting nice pure water, and we don't have to use reverse osmosis. Fortunately, in this country there's plenty of water coming out of the sky, and we don't have to clean it up. It's nice and, well, reasonably clean when it comes down, but obviously when we store it, we do need to filter it. And slow sand filters work extremely well for us. I think they're wonderful because they're biological filters and actually introduce into the water some of the nice bugs, the things that you might otherwise have to buy and put into your compost. They're free with the slow sand filter. So you're getting Bacillus, trichoderma and things like that already in the water that you're irrigating with. A little bit here. I hope we managed to supply what our customers require, and I suspect that's why we are still here, because if we didn't, I don't think, seeing some of you are our customers in the audience, I don't think you'd put up with us. And one of the things that we do find comes around again and again is traceability. Particularly for food crops, we're finding that people are coming to us and saying, will you propagate this, because we want to know where it came from and what it is and everything along the chain. I think the gentleman before was talking very much about keeping track of everything, and that's the critical bit. Customers want to know that they're getting what you're telling them they're getting, and traceability is becoming much more critical in everything these days. And we are able to do that because we have management control of the whole production system. we can trace back to an original stock plant. So when we send a customer plant, the computer can tell us where that plant came from, which plant it came from. Obviously we need stock control because we grow 300 different lines, and some of them we grow half a dozen of a year because they're critical stock plants, and some of them we grow 100,000 of, and we do need to know where those 6 plants are among the 100,000. So stock control is a critical process. Order processing, customers do like to know what they get, and we need to control the production closely and cost it, because we need to know what our costs are, otherwise we wouldn't be here. A few projects that we've been involved in. Lots and lots of species we've done, all sorts of exciting things, from hops to herbaceous things, trees, and recently we've been doing some native species. I actually talked to IPPS some years ago about some of the bilberry and crowberry restoration work that we did, and that's been quite an interesting project, something a little bit different, where we were asked to grow some plants to put back after they'd done this to it. This was an SSSI that Shell took a big bulldozer to, and then we're told that they got to replant it afterwards, so we supplied them with the plants to do that. One of which was bilberry, which in this country doesn't propagate particularly well. Seed germination is very difficult. Regeneration from moved material isn't very good. It doesn't like being moved as a mature plant. It normally spreads by rhizome. So we took some of these plants and put them into culture. We were quite lucky that they actually grew. I think, like propagating many plants, it's often a luck that makes the difficult things work. You do something that you don't necessarily realise you've done, and then it works. So this happens occasionally. And we did the same thing with crowberry, which was another slightly odd plant to grow, but it responded eventually to microprop. And they wean off quite nicely, but they do have specific requirements. They like very low pH, they're low nutrient requiring, free draining. I mean, they're really a bog plant, but they don't like their feet being wet all the time, which is, anyway, don't worry about it. They are slightly awkward, but they do grow quite nicely. And one of the benefits is the microprop gives a bushy plant, which establishes and produces a nice bush very quickly. We did lots of trials on this, planting out into some rather hostile conditions, and managed to get them to establish. We, more recently with bilberry and crowberry, have been planting a lot into the Peak District. In the Peak District, there's a huge amount of erosion of the peat, and huge areas that really, this should all be vegetated. There should be vegetation all over it, and it's all been damaged by pollution, too many people walking over it, too many sheep eating it, and people setting fire to it, or it catching fire. So a huge amount of damage in the Peak District, which is now being rectified. Some of these areas were losing, and some still are losing, a couple of inches of peat every year, just evaporating, which is a very bad idea, because that's carbon that's evaporating into the atmosphere. They can reseed heather, bilberry, crowberry, cotton grass, cloudberry, are all the plants that we've propagated to plant into these areas to diversify it. The process is really, they sort of put a blanket over it to start with to hold it all together, stop it blowing away and washing away. Plant some grass seed, it sort of holds it all together. The grass will only grow there while they add lime and fertiliser every couple of years. So there's a need for the natural vegetation, and that's where our plug plants come in. And we've been able to propagate cloudberry and cotton grass as well, and produce these much larger plugs than we would normally propagate, so that they can be helicoptered up to site. Peak District isn't very accessible. For those of you who may have wandered over it, most of it's quite a long way from roads, and the only way to get these plants up there is by helicopter, which is expensive. So we need a smaller plant as possible that will grow, but something that is big enough to survive. And we've done quite a lot of work on mycorrhiza to establish on the plants before we take the plants and plant them, so that they will be able to get some nutrient from the peat when they're planted. We actually go through a testing process before we do the planting to make sure that there's mycorrhiza in the roots of the plants before they're sent out. And there's me looking stupid. Okay, and we've supplied an awful lot of cotton grass up to Kinder Scout, one of the sort of main areas in the Peak District that people visit and damage as a consequence. It's a very nice place, but a lot of it was damaged, so replanting it with cotton grass has been crucial. There's one problem with all this restoration work. We were able to put back all the bilberry and crowberry and all the other plants, but the Peak District should be covered in sphagnum moss. Now, I didn't actually know that, because having walked up there, there's no sphagnum moss there. But all the peat was produced by sphagnum moss. We were asked by the people doing the restoration Moors of the Future if we could grow sphagnum moss. I said, I don't know anything about sphagnum moss. So it's not even a plant, it doesn't have roots. How the hell do you grow that? However, being foolish, I thought we'd have a look and see what we could do. So we found some very small bits of sphagnum growing in the Peak District, and we went along and picked up some bits. The critical thing about sphagnum is that the eroding peatlands release huge amounts of carbon dioxide. You put back the plants on top, it sort of stops some of that erosion, but not completely. But if you put back the sphagnum, then it starts absorbing carbon dioxide in large quantities. The sphagnum also acts as a sponge. So when it rains hard, it stops the water running off so quickly, and therefore reduces flooding. So it's a pretty critical bit of the vegetation up there. We had this problem that there was hardly any sphagnum around, a few little pockets. This is the biggest bit we've managed to find in the whole of the Peak District. So I think there's square kilometres, 400 square kilometres, something like that. Huge number of blanket bog, and that's the biggest bit of sphagnum we could find. Normally, sphagnum ought to propagate from spores. Unfortunately, in the UK, it doesn't produce spores very much. Our conditions don't work very well. Most of our sphagnum has come in from other places. You can chop it up and spread it, but if you haven't got any, that's a bit difficult. So our approach was to try and basically use horticultural propagation techniques to try and propagate it. I didn't know this when I started. There are a huge number of species of sphagnum as well, and they all have little niches. We took samples, tried to grow them in a glass house, which they did remarkably well, actually. We chopped them up and spread them out on areas and thought, well, this is simple. We can just chop it up and propagate it and we'll get more. It loves water, so using a sort of hydroponic system seemed like a wonderful idea. And they grew reasonably well. If we added a bit of nutrient in the way of compost, they grew even better. And we thought we cracked it. Then we multiplied them a bit further and we found that this nutrient also encouraged algae to grow. And that ended up dominating things, so the whole system collapsed into a gungy green mess. So at this point we thought, well, we're micropropagators, we ought to start micropropagating it, because then we can remove the algae completely. We can put in lots of nutrients and it won't encourage anything else to grow, and hopefully encourage the sphagnum to grow. And yes, we were able to do it. It's a very interesting plant. It would grow on agar reasonably well with the right nutrients. It's a bit fussy, it likes low pH. It doesn't like much nutrient, but it needs some, and it's fussy, it doesn't like specific nutrients, it doesn't like calcium and it doesn't like zinc and all sorts of odd things it doesn't like. But you can grow it, and after a bit of fiddling about, what we thought was wonderful growth initially, we actually managed to turn into something that grows like mad. So, we then had a question of what we do with it. Okay, we better get on with this. So we chopped it up and grew lots and lots of little plants and put them into little gel beads. So inside each one of these there's a number of little sphagnum plants, and this gives us basically an artificial seed, and we did lots of trials on trying to get them to grow. They grow quite nicely, sprout out. Did lots more trials. They grow quite big in the glass house. We did lots of trials on drought tolerance and cold tolerance, and field trials planting them actually in the Peak District. Lots of scientific trials testing how's the best way to do it, and what conditions you need to get them to establish. Yeah, that's one of our little beads in the wild. They tend to turn white when it dries out, but the bead material, the gel, dries around the little plants and protects them, and they will survive and start to grow. And they grow very slowly up there because it's cold, but eventually you'll get little sphagnum plants starting to establish. In the summer they tend to go white and dry out, but then when they're re-wetted they turn green again and start growing. And we've got quite large numbers of them in a fairly small area, establishing quite quickly. Lots more pretty pictures. Now, one problem we had was that where they're on peat that's sort of slightly loose, the peat moves around, coats them, and you can't see them. So actually monitoring things was a real headache to try and find them. And we found that in some of our trials, things popped up 2 to 3 years after we'd planted them, because we couldn't see them before that. More recently we've been planting into established moorland, and they do quite well in there as well. So not only can we do the areas where they were denuded, we can do areas where there's already vegetation. And our beads lend themselves to being planted by helicopter. because they can be put through a seeding machine and basically sprayed on. The other area that we know as horticulturalists as where peat comes from is peat bogs in lowland areas. And having got sphagnum to grow in the blanket bog in high areas, we were then asked to look at harvested bogs and see whether we could restore these. Because when peat's harvested for our use, you tend to get these sort of areas which are just bare. The vegetation doesn't come back into a peat bog very quickly at all because it's almost sterile. There's the peat's all been scraped off and there's no vegetation there. It's very low pH. It's a fairly hostile environment and sphagnum won't re-establish in that itself. Eventually you'll get a certain amount of grass species, but you tend to get a lot of undesirable rushes and such like, rather than the sphagnum that ought to be there. So we've been looking at doing some restoration on some of these cut over peat bogs so we can put back the sphagnum and grow some more peat so we can use that in 1,000 years' time. Well, got to look to the future, haven't you? So this is a cut over peat bog in, it was actually Belton Fell, I think, this one. The other problem with these surfaces is that they tend to be fairly mobile. You get a bit of loose peat on the top and it blows around and the surface doesn't really stay very still. So there's a need to put in some sort of cover to protect the sphagnum while it gets going and stop it being blown away and moved around. And we've looked at putting chopped heather, brash, straw, even plastic covering, and in this case planting cotton grass plants as plugs. And we found that system works quite well actually, because cotton grass is a desirable species to put in there anyway. And the cotton grass works very well as a sort of nurse crop, and the sphagnum can start to grow in the base of the cotton grass and form a carpet underneath it. It will grow with the heather brash as well, so that's an alternative method. We think we've got a wonderful product here that's going to grow, be able to restore sphagnum on a large scale in areas where it's not been possible to get sphagnum back previously. Okay, I hope I've managed to tell you a little bit about Microprop, and I hope there'll be a lot of awkward questions later as to what I've missed out, why we're still here, which I'm hopeful is not just because we haven't noticed that we're doing something wrong and everybody else did. My bank manager hasn't told me yet. He keeps hinting, but anyway. And I hope you like our new planet-saving product. Thanks very much.